All right, I'm going to look at a tangent graph now. Same process. We're going to locate the period or calculate the period first. So I'm going to go ahead and get my pen out. And since we've been doing this, let's go ahead and factor this 2 out, since we know we're going to need to factor the 2 out for the phase shift, and that way we'll have that done. So the equation really would be 3 tangent of 2 times the quantity x minus pi over 2 plus 1. And then my period for tangent and cotangent are half as much to complete a cycle as it is for sine, cosine, secant, and cosecant. So instead of it 2 pi over b, it's pi divided by b. That's the reason why when we were solving equations, it was okay to do plus pi k instead of plus 2 pi k when you did tangent and cotangent. So my period is going to be pi divided by b. In this problem, b is right here. It doesn't matter if it's factored out or not, so b is 2. So we're going to have pi divided by 2. So there's my period. Pi divided by 2. Asymptotes, domain, and range will come back and catch at the end. Now I want to get the phase shift. It's going to be right pi over 2. And the vertical shift's going to be up 1. So the way I do this is I lay down one period for the function. So I'm going to go pi over 2. And I only have to do half as much, so I'm not going to do quarter marks, I'm just going to do half marks. So it's pi over 4. And so 1 pi over 4, 2 pi over 4, if I want to go 1 mark past that, that would go 3 pi over 4, just in case we have a phase shift, which I think we do. And then I can go left pi over 4 if I want. And then left pi over 2. I don't know if I need to really go past that. So I've done my period, I've got my period done. Now I'm going to do my vertical shift. It's up 1. Now that's going to be a big deal. We didn't look at that today for tangent and cotangent, but it is up 1. So now, if you remember what I said in class, and I said it very quick at the end of class, tangent always starts with an asymptote at the half mark and a point on the y-axis. So if you want to think of it, I'm just going to use just red real quick. I'll change colors here for a second. Just imagine in red here, there's a point here and there's an asymptote here. Well, I have to shift the point and the asymptote over pi over 2 to the right. So you got to pick one of them up and move it over. It's probably easier to move the point since that's from 0, because that point's going to go over to pi over 2. So I'm going to erase that here so you can see that now. So let me just erase that asymptote. Get that out of the way a minute. So this point here then, if I'm looking at this point, it's got to shift right pi over 2. So this is where my new point's at. And it's going to go point, asymptote. And then it'll go point, asymptote. And then point, asymptote. And then point. Now there's one other thing that I've forgotten to do that you've got to remember to do, and I want to make a point here, is I've got to shift these points up 1 now. This point's got to go up 1, this point's got to go up 1, this point's got to go up 1, but that doesn't do anything to the asymptote. So my graph's actually going to be located here, here, and here at that imaginary line at 1 because of that phase shift, or sorry, vertical shift, and this is a tangent graph, which will make right-handed disco curves. Now another thing again, to talk about cotangents, left-handed disco curves, there is a way to make tangent left-handed and cotangent right-handed, and that's if you introduce a negative out front. If I was to flip this, you actually flip it from left-handed to right-handed. So there's my tangent graph, and remember, tangent starts with a point on the y-axis and an asymptote at the half mark, and our half mark this time was pi over 4. And then we shifted the point right pi over 2, and then the asymptote got shifted right pi over 2, which brought it over to 3 pi over 4, and then it's just follow your pattern, point, asymptote, point, asymptote. So my asymptotes equations will be the start, which will be, let's go pi over 4 for a start, plus, it's not half multiples of the period, it's actually multiples of the period, because you complete one cycle between asymptotes, so it's actually going to be pi over 2k. Then your domain would be x cannot equal pi over 4 plus pi over 2k. And then the range is just going to be all real numbers, which is really nice for tangent and cotangent because it goes up and down forever. And that's how you graph this tangent function.